that have these trillion-dollar brands to want to, engage with a relatively still small company around a critical technology in a critical product they have, right? And so, start to finish, from the time you first introduce a new idea in the hard tech space to the time you get it on a product platform, at least a decade.
So welcome to this week's Leaders on a Mission. I'm your host, Simon Leach, and today I'm really excited to host Craig Bandies, CEO of Pixelligent Technologies. Pixelligent Technologies is really at the forefront of advanced nano-composites materials that are really helping drive these better visual experiences and energy-efficient devices. And look, Craig has a fascinating journey. It's really one of perseverance, skillfully navigating market shifts with a mix of talent and well-timed opportunities. And Craig, I'm really delighted to have you come on the show, and really look forward to diving in.
Yeah, thank you so much for the invitation, and I'm looking forward to it.
Awesome. So, what's really interesting, right? You've been leading Pixelligent as a CEO for over 15 years, I think it is now, which is a significant tenure in any industry, right? Especially one of advanced materials. So, what have been some of the kind of, I suppose, defining moments for you personally when you think about this kind of journey?
Yeah, it's a good question. I think there's been many. I came into this without really having a background in the chemical industry. I didn't even take chemistry in high school. I took some physics, right? So it's been a pretty steep learning curve. My background before was helping to, raise capital, form companies, build teams, bring new products to market of all kinds, software, hardware, services. And so for this one, it was having to really learn not just a brand new market and industry, but a lot of just sort of the fundamentals of how these products are put together using this brave new world of nanotechnology that's been up and coming now for the past 40 plus years. Starting to work with a different type of team, very technical. When I first took the company over and took us at bankruptcy with some backing of some local investors and myself back in 2009, I joined a team of roughly 8 PhDs, and that itself was a brand new experience of how to work with and manage and motivate and even just talk to each other to try and form a business around, a really valuable, compelling technology. And so I think that was the beginning of it, of just, knowing how much I didn't know. And in some ways, that was a bit of a benefit because I also didn't know how hard, I guess, it was going to be. And in some of the challenges that, if I knew then what I know now, would I've taken on the gig? I don't know. It's a hard thing to answer. Right? So I think it's been a lot of trying to build a new company or resurrect a company and make it new again. In a still early developing industry around these very amazing new materials around nanotechnology, and then try and find a way to get ourselves navigated to the largest consumer electronics companies in the world, because we've learned a lot about, it's much easier to go from top of the guys that make the decision and then have them push you down through their supply chain, then try and convince their suppliers that they should, work with you and go present you to them. And we learned that the hard way. So I would say, there's been learning the industry, learning how to, manage and grow and motivate a very technical team, having to raise capital, we raised, to date about $110 million of equity and debt capital, form, partnerships with some of the biggest companies out there. And so, it's been a lot of firsts that we've done, a lot of firsts that I've done for myself in terms of learning how to figure this out, to help us get to the point where now we're engaged with every significant consumer electronics company in the key markets that we want to be in.
Yeah, awesome. And do you think it's like thinking about the chemistry background? Is it an advantage or disadvantage? Because at that point, it's really early with PhDs. And you haven't got a chemistry background, can you use that to your advantage when you're taking on a role as a CEO of an early stage company that you're not schooled in that technical kind of background?
It can get both ways, right? I think there's good sense in having a more fundamental background in that. So I relied on the team that was in place. They had some good advisors on the advisory board who had come from industry, so I relied heavily on them, and they were some of the key folks that actually convinced me to take the leap. That they'd help support me on that part of it, and they did. But I think on the positive side of it, I was less focused on exactly how these really incredible nanoparticles were being made, and more, why are they valuable and who's going to buy them, right? And so a lot of what I was focusing on was, okay, I want to hear a lot more about the benefits versus the features, because that's how we need to go sell this. And that took some time, because I just kept saying, okay, so why does anybody care? Why does anybody care? And a big phrase I brought in that's still in the company is, we don't work on science projects. It's got to be a business. And so it also got me to focus on, okay, so there has been, at that point when we got involved in 2009 with me and the investor group, there had already been $4 or $5 billion of venture money had gone in circa 2000 to generally the field of nano, about 15 or 16 billion through government, through the Nanotechnology initiative, which was putting money into agencies to go fund companies like us through the DOEs and SBIRs and NSF type of grants. And then, billions of dollars in corporate, and very little had come out at that point. And so what I also realized was there was so much effort around the invention of the particle and backing companies like a Pixelligent before I was there, and not enough on, okay, well, how do you make this at a scale that somebody that's big can buy at a price that they can afford, and with a supply chain that's reliable? And because they were so focused on the science, that business stuff, well, we'll figure that out later. And the problem with that is they would spend all the time, a lot of those early stage, initial companies in that early stage, making these really amazing particles that were rare earth, that you couldn't control the price because they were coming in from places like China, and that could change on the day, or they were so toxic you couldn't put more than a kilogram in your building, and none of the big environmental safety and health groups inside of a Fortune 500 company would let it go in their door, right? And so, or it was so expensive to make that you could never get to the economics. So a lot of what we did initially was, okay, we're not going to make anything in the lab that we don't think a customer could actually afford to buy and will be safely brought into a production line. And so we started focusing on the manufacturability of the material that could go into a device ultimately, instead of just the particle itself. And I think that was an important part of the shift. And then just trying to figure out, okay, how do we go after markets now, and what do we have that's important and valuable? And it turns out the technology they had been working on before I got there was for a semiconductor-related application. And essentially, they created at that point, which we still have today, is really the world's best dispersion technology. So that means a customer can send us in a material, a monomer, or we use a solvent that's crystal clear and looks like water and has viscosity to like water, and 100% of the weight is that thing, that what's in that jar. We now put our nanoparticles into it, and now 80% of the weight is us, and it still looks the same transparency, the same viscosity to the eye. And so we're able to take a lot of material and concentrate it in that system to create a lot of benefits, which for us is optical benefits to make devices brighter, more battery efficient, more create better focused images in front of you for things like augmented and mixed reality. And it's all based off of that main fundamental breakthrough that the company focused on, that since then we've been able to bring into many different areas.
Awesome. So essentially that dispersion technology you're talking about, initially you look back, the main application it was focused for was more semiconductors, and you had to kind of pivot, and where you play now, for instance, the markets you serve, that kind of evolved.
It did. Yeah. I mean, so, the first concept was trying to double the amount of transistors on a chip, which would have been amazing, but super expensive. It's on the front end process of the semiconductor process, which is really hard to break into. And so we were working with two very large companies in that space. And when we came out of restructuring and said, okay, if we're going to do this and continue to work with you, you each got to send me $10 million to continue the effort. And they said, we like it. We don't like it that much. And so that was sort of the end of that. And then we're like, okay, well, what are you going to do now? Right. And, when we were raising the capital to get out of the restructuring process, it was 120 pages of, mainly semiconductor description. And then, 2 paragraphs of, and we think it could have work in other areas like electronics and other things. Right. And that became really the business strategy going forward. So started going to advanced materials conferences, and started, presenting rather the what we had in terms of this dispersion capability. And so the first area that interest came into us was from the solid state lighting area, both LED lighting and what was called OLED lighting, which never quite made it to market, even though we were very engaged in that for the better part of like 4 years. It's coming back now. LEDs are everywhere, obviously now in your house, in your phone, in your laptops. And so that the ability to try and get more brightness out of those chips was the first area that we worked on, and we worked on it diligently for about 4 years. Did partnerships with some of the biggest companies in that space. Wound up raising, I don't know, $15 or $20 million around that support of that. And as we were getting close to bring that to market, the Chinese market in LEDs were able to find a way to make the high-powered chips that were going on much more economically, and it made it difficult to bring our technology now into that market. At the same time, the OLED lighting market, we were working with one very large Korean company who was the main company that had invested almost $500 million behind it, and we were the key enabling technology in how the brightness came out of these really beautiful panels. Decided the market wasn't ready for it yet and shut it down. So those two things happened within 6 months of each other in 2017. And I really thought that was pretty much game over at that point. And then we had a pivot again. And luckily, we had at that point been going around the world. I spent a lot of time in Asia, been going over, 3 or 4 times a year for over a decade now. And we did try to start to open up other areas. And so then areas of display started needing these high index materials to make devices more efficient and brighter and have batteries last longer. And then this brave new world of augmented reality was just starting. And so thankfully we started getting interest in those markets, which is what really bridges us into what we're doing today. And so, it's as everyone knows, it's never a straight line. It kind of goes like this, and hopefully just always moving this way and, not going that way. So
what these markets move, just quickly on what you said there, the OLED marketplace, what was wrong? Why didn't they move forward? And you said it's coming back now. Just tell me a little bit about OLED and where it fits in.
So there's 2 flavors of OLED. There's OLED that's ubiquitous today in like your OLED TV that LG sells. I have one and they're amazing. And OLED is the Samsung Galaxy device. Their mobile phone is based on that OLED. The OLED that we were in at that point was OLED lighting, which sounds similar, but the technology is very different. And ultimately, the challenge with that market was that although the light was the most, and it still is the most beautiful, soft light where you can look into it and not squint, and it lights up a room beautifully, the cost per panel was just too high to compete. And LEDs kept getting more and more efficient, and the form factor changed. And so that essentially was not going to be the size market that the Korean partner felt. And they were right. In hindsight, they were right. I mean, the market really didn't develop. They probably would have lost billions of dollars of marketing it. At this point, you look at all the analyst reports, it should have been like a $10 billion market today, right? And it's still tiny. And so they pulled that out. They pulled out of that market rather. And so we then had to scramble. But OLED display, our materials provide a similar benefit, even though the technology platforms are very different, of getting more brightness also. So in the world of OLED displays, you have these emitter materials like green, red, and blue, and energy hits them and they glow and they're very vibrant, but they're also dimmer than LED-backed LCDs. And so you have, if you put a device together, typically an iPhone next to a Galaxy, the Galaxy's colors will look deeper, but the iPhone will be brighter. And so we are now working in that field of OLED display and have been for the past 4+ years to take our materials inside of these devices to also make them brighter. There's a new path of OLED display coming out where mainly OLED displays were pretty small today. They're in galaxies. They're now going into tablets and soon your laptops because it is just a higher quality color display. There's other manufacturing benefits as well. And so we're actively involved in helping to push that as well. And these, again, will make screens brighter, batteries last longer, have other benefits as well in terms of, reduction of heat and those sort of things. And so that's kind of where we see, and OLED in display in particular is really going to replace not all of LCD, but pretty much all the big plants throughout Asia are being transitioned from LCD to OLED or OLED plants to make devices. And so in the next 10 or 15 years, OLED will be the more ubiquitous display platform versus what's been around the last, 40 years with LCD.
Right. Okay. Amazing. And in terms of the markets then now that you focus on, talk through, you mentioned about some of this extended reality. Is that the main one or just maybe talk through those markets?
I would say for us, the lion's share of our effort is in this brave new world of extended reality. And extended reality is like, it's an umbrella, right? So you have virtual reality, think of the Oculus devices. You have, mixed reality, think of, what came out from Apple with the Vision Pro, but also what Microsoft has had out there for a long time with the HoloLens. And then augmented reality, which are glasses that look like mine, right? And this is where the market really is going towards in the future. The first Meta Ray-Bans are just, smart glasses. Now they have some AI in them. They've got a camera. But ultimately, augmented reality means that there'd be a layer that you would think, it seems that it's in front of your glasses. It's actually, it's an image that's reflecting off the inside between your eye and the lens. And it gives you a sense of additional information and overlay of your reality. So whether it's directions that you can see or emails or a video call you could have with somebody while walking around, like that's the whole mess, what comes next in terms of the market. And so the messaging right now has all been about, we're going to start with smart glasses, and then we're going to get to augmented reality. And so we are spending a lot of time throughout the entire supply chain, from the large consumer electronics companies to other material partners we partner with, to the ODMs that make these devices all throughout Asia, to put our high index materials in these AR headsets and MR headsets to make a much crisper image, increase the field of view so that you can see more of the image, make it a more efficient light path, which will also make the devices more efficient. And so we are very active in that field. And with all the breakthroughs we're seeing in the news every day from companies like Meta, and what will come out next, I think, from Apple, and some of the announcements even coming out now from Samsung, this is definitely a matter of when versus how and if. So we're pretty excited about where this whole industry is going, and we're, I think, one of the leaders in that space from the optical material side of things.
Okay, awesome. So when we think about extended reality, that incorporates virtual, mixed, and augmented together.
That's right.
Does that?
That's right. And we focus on mixed and augmented reality. And so when you think about what's happening even in the exploding world of AI, right? The AI and XR are basically force multipliers, right? Each one really dramatically improves the other. So for AI, you need an input and an output device, right? In fact, OpenAI just announced that they hired Johnny Ives and a key hardware person from Meta to start working on their own device, right? And it makes sense because, if you're going to be walking around a city and you want to have some contextual information, of what you're seeing around you, or, find restaurants or, get information about a product you see in a store window or whatever, you're looking for, there has to be a way to get the information in, which is going to be something that's capturing your surroundings, go up to the cloud, and then have the AI come in and give you the contextual information you want to then go make it actionable. And so these are going to be tied at the hip, and you're seeing more and more of the devices, going from, the Ray-Ban Meta smart glasses, which were just cool glasses, nice form fit factor and a camera, to now having AI in them, and then music, and you're seeing an evolution to what comes next. But as AI goes, I think so does extended reality. Critical for things like robotics, really anywhere where you really want to have the ability to have the flow of information in and out, you're going to need a piece of hardware, and it seems pretty clear that that's going to be some kind of extended reality device.
Yeah. Also, I read somewhere that the market for this is somewhere in the region of about $20 billion for extended reality, with with estimations for it to grow to 100 billion, I think, by 2030 or something, which like really significant growth. Is that roughly? Have I got my numbers roughly right?
Yeah, I mean, they're roughly right. I've seen some numbers that even peg that 5x that high end number. I think that would be a little heavy, right, in terms of where the market's going by 2030. I think the challenge has been the aha moment when they become the next true one of these out there, and the question is, does it replace it? I don't think it ever truly, or at least in that period of time, replaces your smartphone. I think they're going to be tethered together, although through Bluetooth, not through a cord, and they're going to be very useful to have, to be able to use a smart device to be able to hit the cloud and serve up information in a very efficient way. It deals with some of the power and delay issues in terms of getting the images you want to see. So I think they're going to be very much connected. Over time, we'll see if it truly is a replacement, device. There may be some areas where that can happen sooner than others, but I think when you have really every major, both well-known consumer electronics company here and then throughout China, and the supply chain lining up, and having all the equipment companies that make what are called the nano imprint tools that put our material in a structure on the lens that sort of enable what you see in front of you to be clean and crisp. That whole infrastructure, everyone's spending tens of billions of dollars to get it installed now. So I think those numbers seem right. Is it 2030? Is it 2032? I think that is the question of how long will it take to sort of hit those levels of numbers.
Great. And your product, just to talk through what your product does and the value it kind of it gives these these systems, as it were. You mentioned crispness. Talk a little bit more about that.
Yeah. So when you're having an image in front of you, right, it's all about how well you see the image and how well the image stays so only you can see it. So you don't want people next to you to watch what you're watching. If you're on a conference call with someone, a friend or your loved one, you want to have that private. And so you want to have that. You want to have the ability so that, when you move around, the image stays, with you, but not jerky. So you don't get that seasickness feeling. And you want to have a really wide field of view, or what's called an eye box. So, an example you give is that in many of the current devices you have out there today, if you're projecting a rose through it, you kind of see, the bud and like 4 petals, if you have a 20-degree or 30-degree field of view. When you start talking about like the 70-degree field of view that Meta talked about with their most recent release, you then see the whole rose, right? And the stem, all the petals, the full vibrancy of that, of that image. And so you want to be able to see as much of that image and have it be as robust as you can have it. And so having the optics right, with what's called a waveguide to really improve that is everything in terms of how your eye will interpret that image. And that's the area that we work on, in that device. And so, I think, there's been other material companies that were out before we were. I think because we are very unique in how we make our products. So because we make the nanoparticle itself, we start by synthesizing the particle. These are really small. These are between 3 nanometers and 10 nanometers in their core. One strand of your hair is 60,000 nanometers in diameter. So controlling particles that are 3 nanometers to 10 nanometers is really difficult. And there's only a handful of companies in the world that can do that. Most of them are significantly larger than we are. And so we make the particle, we then control the surface chemistry that then interacts with other material systems to deliver the final application. Pretty much everyone else we compete with is buying a third-party particle that is not as good and is not specifically made for that application, and they're having to work around that. So because we can tune all of the knobs and create everything on our own, we really can deliver, I think, the best, most robust product in the market. And that's a shift for us. Up until 2019, we only focused on the particle and tried to partner with these other chemical companies, and they literally were testing us to death. And we, after years and years and years of trying to go down the path of convincing these big chemical companies that we can reinvigorate their product lines using our particle, we realized we had to do it on our own. So then we started making the full formulation, the full product, starting in around 2020, and now that really is the focus of where we are today as a company. And the other key differentiator for us in this, it's no longer in the world that we play in just the effect in terms of the end result for the how the product performs, but it's also what's the environmental impact of what you're making, right? And that is becoming and needs to become increasingly important. And so everything that we make is what's called PFAS free. PFAS are these forever chemicals that are in most big chemical companies' products today. Many of them, if not all of them now, are trying to find ways to take those out, but that is difficult and time consuming and expensive. So in working with us, we come to market with already a environmentally responsible, high value PFAS free material that can also deliver all of these key properties to drive all these new products in the market.
Just tell me, I remember reading on your website about other areas as well, like things like surgical or retail or education. I mean, is this world, are there other segments and markets that you see you serving over the next few years?
Yeah, so with extended reality, those are all those markets, right? I think the initial wins are going to be in medical and in industrial, and you're seeing all this happen already in education. The ability to have a textbook in front of you, right, and see the images, or if you're in medical school and being able to project in front of you like as if you're doing a surgery. Some of that technology has been out for a little while already. There's even I live here in Maryland. There's a builder in Baltimore who, as they were getting ready to start to market the building before they broke ground, they had a virtual reality headset you could put on, and you could arrange how you want your apartment to be set up, and they sold out before they broke ground, right? And so there's just so many cool applications as you think about where this can go before it's a consumer device that we're all wearing. That's for XR. In the other areas in display, we talked about an emerging market for us is in sensors. And so the ability to capture more data and more light, which is a critical part of how data is transferred in sensors, and having a higher index material can have a lot more utility there as well. And so we have the ability to make sensors that can capture more data in a closer proximity. So think of things like in your automobiles, you go to self-driving cars. There's a need to monitor driver interaction, and so there's a lot of focus on sensors that can work in nearer field environments. We have technology that can do that. As you go into trying to have better and better optics in some of the camera modules, having high index materials there, it can start to shrink some of these. And one of the cool new areas in that is something called meta lenses, where you'd have almost what will look like two-dimensional lenses that can capture light and move light in all kinds of really cool ways. And we have a key material that's supplying into that market today for companies that are making these meta lenses as well, that have a broad set of applications across multiple industries, from lenses to sensors and other areas. And so, a key driver for us is, up until about 5 years ago, the refractive index of the materials that were in the market were really good enough. And now there's an acknowledgement really by everybody in the sectors of extended reality, display, sensors, that it's not, and that to get to the next level of performance, you really need to have higher index materials, and we are one of the key leaders in that space right now.
It seems like this market is evolving perfectly for what you can provide and the value that you can kind of bring to this new world, right?
Yeah. I wish I would have known that a few years ago because it's been a pretty rough last 5 years and waiting for the market to catch up to the technology to a degree. A lot of what you have to do, I believe, as a hard tech company, you have to have staying power, right? And we've had incredibly loyal investors that have backed us to this point. We've had, for the most part, family offices versus traditional venture that have helped get us here. We have some institutional capital in the forms of some debt financing that we raised a couple of years ago. And then we just announced a big partnership with a multinational company in our space called Henkel, who are now a big strategic investor and a partner for us to help us really expand the company from here on a global basis. And so, all of those things happen because we build a reputation over time, right? And so going to Asia for a decade, it takes a long time to get, companies of the scale that we work with today there and here in the US that have these trillion-dollar brands to want to, engage with a relatively still small company around a critical technology in a critical product they have, right? And so, start to finish, from the time you first introduce a new idea in the hard tech space to the time you get it on a product platform, at least a decade, right?
Wow.
At least a decade. And that's if things go well, not if you have some fits and starts and turns along the way. And it's expensive, right? And so, in our market, it's not uncommon to see companies raise anywhere from $100 million to $300 million, before you get something into a commercial win. So not quite as expensive as the biotech, world these days, but sort of 1 degree away from that in terms of capital and difficulty, I think.
Yeah, absolutely. And I would imagine, just a couple of things to unpack. You clearly made the strategic decision to go straight to the customer. You said initially you were doing the actual particles themselves, and then you made almost like the full kind of material, as it were. How difficult so it enabled you to bypass a stage in the supply chain, right? You were going directly, therefore, to customers. The big consumer electronic companies. What were the real kind of challenges with taking a move like that, as it were, moving up the value chain?
So I would say a lot of it was, I can't tell you how many times we've presented our technology in these conferences over the years in sort of display or optics generally, or high end value, or advanced display materials, or just advanced material conferences. And all these companies send people to them, right? There's R&D folks always trying to find what is the next thing. So I would say people are looking for new technology in these big companies all the time. And so what, I can't, without revealing the name because we all have NDAs, but one of the biggest consumer electronics companies out there, I was in a senior person's office, it was 5 years ago. And he, we had met through the network I've built over time. And it's like, hey, listen, we're believers in high index material. You're just making it too hard to do business, right? We don't know what to do with the particle. We need something that we can take and, put into a film and make on our devices. So you're asking us to, take your particle and have you work with one of our key vendors who, by the way, we don't reveal who they are to anybody. And so we'd like to work with you, but you got to make the whole thing or it's never going to happen. Right. And after hearing that enough times, it seems obvious in hindsight, but it meant doubling the size of the company in terms of resources, right? Because we had a whole team focusing on just the nanoparticle, which itself is pretty complicated to make, even though we can now do it in tens or hundreds of tons of ability and to get product out the door in terms of capacity. But then to take that and then build a whole new team that now knows how to do the complete formulation of a product that includes our nanoparticle, but also lots of other additives that go into a formulation, was something we just hadn't done. But we decided, okay, we have to do it because otherwise we're not going to make it, right? So as soon as we made that decision, the world has known for a while. There's been a lot of white papers out there and discussion about the value of a high index material. So we didn't have to make that case. And so most of the customer opportunities we have are really inbound. I'd say 80-85% of them are inbound, of saying we need a high index material that can do this for us in making a material brighter or making a better focus in our device, or capture more light, or any of the above, right? Or a combination of those. So, it's a known thing, and they were in many ways searching for the right product. And now that we can complete and make the full formulation, we now have that product. And so all of these big CEs that we work with, ultimately, none of them really make the full product themselves anymore. It will get pushed down, into their supply chain and into their key, ODMs, device manufacturers for that make ultimately these devices for them. And so now we are working with those guys as well, in that supply chain. And so I would say it was the combination of just pounding the pavement, talking about having the highest quality, high index particle for a while. And then it just made it an easier conversation once we could provide the whole formulation.
Yeah, no, great. Now, it's been some journey, right? You've outlined these 15 years. Where now from here? You sound like you're at a great space with a growing market. You're doing something, I'm right in saying, super niche, right? There's not many companies that can do what you can do, right? Well, where'd you go from here? How do you see the next 15 years? Without scaring you too much.
Yeah. So, well, yeah, I would say, we are, I think, finally in a really good place. It's taken a while to get here and to create the market position that we have. I think we now have the right mix of products. We're really working with every major and smaller, mid-size company in the three core markets we care about in XR, display, and sensors. We have as much as we can kind of handle at this point in terms of effort in getting products specified into these devices, and we have now an excellent global partner in Henkel to help support us in really all of these activities. We share many of the same customers. Having a company like that backing us gives us not just great credibility and access to some capital, but also it gives larger companies out there, some of the biggest on the planet in this space that we play in, higher degree of confidence that with them and as a partner that we can deliver at the scale we need to deliver at. So it's all a matter of execution right now, and getting spec'd into all of the next set of devices and next generation of devices in display, in really the first or second generation of XR that's coming out over the next 2 to 3 years. And then following suit with what we're doing, in the world of sensors. So I think we have the right team, we have the right partners, we have the right capital base, and I think it's at a point now for us just to put our heads down and execute like crazy.
Great. That sounds it sounds awesome. And with Henkel, I did see that when it came out. Is that, for instance, a relationship that you've nurtured for a long time? I mean, what makes them? I know they obviously share the same customers, and they're obviously a big global player, and I can understand that. But I suppose when you're getting into a partnership with a company like that, for you, what's the most important thing when you're kind of moving things across the line in a key strategic partnership?
Oof, it's a big question. So, and lots of lessons learned on this one too. So we have we've done partnerships with others in the past that have not ultimately played out the way we had expected or they had expected. Best of intentions going in, I think, to those partnerships, and very high quality companies. But there's the thesis you have when you start, and then there's the practicalities once you really get started and dive in. And so, what we learned through some of the prior efforts we had done, and we spent about a year, and we had investment bankers working with us to find the right partner as well, talking to many potential global partners. We had the most interest in Europe and Asia, which is a little frustrating and disappointing that we didn't see as much of that coming from the U.S., because I think we are unfortunately in the U.S. falling pretty far behind on these leading edge applications to Asia and Europe in terms of advanced materials. And so we worked through, the process and down selecting to, from, call it a dozen or so, down to 3, through through that process. And then ultimately it was came down to, who do we think we have the best fit in chemistry with, because that is so important in these partnerships. All of them had been working with our materials on and off for years, and so they already knew the value and quality of what we made. And then it was, okay, so whose business model do we fit best with? Where's the best complement? Where do we think we could really leverage each other's capability? And which of the three do we think is really going to be open to hearing our thoughts on how to move forward? Because there is sometimes big company, small company. Some of these big companies, you get some of the not invented here. Inside, once you start to get into the real worker level, once you get past the executives that cut the deal. And I would say, in through every one of our interactions really with the team throughout Henkel, it was very much a partnering mindset. You guys bring something we don't have, we bring something you don't have, and we really want to help you be successful, and we want to have you help us get into new markets and create new products for our core customers. And we think, working together, we can, create a lot of value. At the end of the day, it's still always a leap of faith, but, we are just about 3 months post-close, and we've already been around the world meeting with all of their key people in the key offices that are important to us and that we're important to. And we're already interacting and pitching customers together and talking about new product development efforts and ways they can support what we're doing. So I think we're off to a really excellent start. But it takes effort, right? We have a team dedicated to it. We have my sales team working with their sales team, on a weekly basis. There's monthly update calls. There's, weekly calls and, amongst the technical teams that are working together. So it does. It definitely. It also takes a great deal of effort to make sure that you're going to get out of it what you put into it. But if it works as planned, it will be, I think a critical step in our overall success here as a company.
Oh, amazing. Absolutely amazing. And I could talk to you all day about this, honestly, but you've shared some, fabulous kind of insights around like your personal journey, over the last 15 years with this and before that as well, right? So really inspiring to hear how Pixelligent is shaping the future of advanced materials with this kind of innovation and vision. And Craig, seriously, I really, thank you so much for coming on the show. You've shared so much today, very useful for our audience. So thanks so much.
Yeah, no, thank you for inviting me. I enjoyed the conversation as well, and look forward to the next one.
Awesome. And thanks to all my guests for tuning in to a great episode this week with Craig. And don't forget to subscribe. Thanks for tuning in, and catch you on the next show.